Good morning, grade 9s, and happy greetings to all of you today. Welcome to Worksheet Cloud Grade 9 Natural Sciences. If you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com and we'll try and get back to you with the answers as soon as possible. My name is Mrs. Ernston, and I am the Worksheet Cloud Grade 9 Natural Sciences teacher. I'd like you to be ready for today's lesson, so you'll definitely need your pen and paper and something to write with. And for the beginning of the lesson, if you've got a ball handy, it would be really helpful. So, what are you grateful for today? Who are you going to connect with or check in on today? How are you getting outside today? What exercise are you doing today? How are you being creative today? And what are you going to do that is helpful? During this time, grade 9s, it really is important that we look after ourselves and those people that are around with us. So I hope you take some time today to reflect on a few of these things. The topic of today's lesson is the naming of compounds. So each compound has a unique name and formula. The formula of a compound tells us which elements are in the compound and how many atoms of each element have combined to form one molecule of the compound. And today you are going to learn the rules for naming compounds and how they take into account how many atoms of each type are in one molecule. I hope that you managed to find a ball around the house, because I really have a fun activity for you to do at the start of the lesson. And if family members are around, they can get involved as well. So this is just a recap of the elements and their symbols from previous lessons. So you can be creative and you can make up your own rules and your own game. But one suggestion that I've got is you can throw a ball in the air, or you can get someone to throw a ball to you, and you must either say the element, spell the name of the element, or call out the symbol before you catch the ball. So here I have given you some of the elements with their symbols, but what I've also done on this following page is I have given you the names of the elements with their symbols, so that if you are playing with a family member, they are able to help you along in this game. So if you're going to do this on your own for a moment, we can go back to this screen here. You can press pause and you can see how many of these elemental names and symbols you can remember. It's always good to have a copy of the periodic table available while we are going through these lessons. So if you've managed to download and print a copy, that's great. If not, I've put one in for you and you can keep on referring to it through the lesson. So if you just need to remember that you need to be about 4 minutes into the lesson if you need to come back and refer to this periodic table. But hope you've got yours printed and ready. So just to recap from previous lessons and to engage in this lesson, I have given you a ball molecule here and I have given you a chemical equation. I would like you to see how many things you can write down when you see these diagrams, or what can you remember, or what kind of information does it trigger for you. So if you need to pause the screen, you can, and give yourself about 2 minutes to write everything you can remember. The next activity I would like you to do is using the information in this diagram below. I want you to be able to explain why it is important for each compound to have a unique name. If you need to pause for a moment, you can stop the video while you write down your answers. So if I give you this diagram here, so it's got an atom of sodium and it's got an atom of chlorine. How do we go about naming this compound? Do we call it sodium chlorine because it's the name of the two elements? Or do we call it sodium chloride? I wonder what you think the answer is. Well, let's go and see. So, for chemical formulae for compounds, they are always a combination of the symbols of the elements in the compound. So when we speak about sodium, we go back to the periodic table and we see that we represent sodium with capital N lowercase a. And for the element chlorine, if we go to the periodic table, capital C lowercase l. So for example, the formula for this compound over here is going to be NaCl. But how do we know that it's NaCl and not ClNa? So let me explain that to you. The system for naming compounds was developed by the International Union of Pure and Applied Chemistry, which we call IUPAC. The system is designed in such a way that the name of a compound describes the elements it contains and how they are combined. The IUPAC system for naming compounds is very complex, but we do not need to learn all of its rules in grade 9. Okay? At this point, we only need to learn how to name compounds consisting of two elements. Now, I know your teachers back at school might want you to learn the naming of compounds with 3 elements. I will mention it at the end of the lesson, but be sure to go back and have a chat with your teacher when you get back to school to find out exactly what it is that your teacher requires from you for this year. So a very important thing to get right for this lesson is we need to look at a bit of English, and that is, what is your understanding of a suffix, and then what is your understanding of a prefix? So please will you remember that a suffix is something that we add to the end of a word, and a prefix is something we add to a beginning of a word. And this is going to prove to be very important as we start learning how to name these compounds. So we're going to start off with compounds that are made up of a metal and a non-metal. So when we get to writing it, the rules that we follow is the following. The metal comes first and the non-metal second. The name of the non-metal changes slightly. We add a suffix I, D, E, which replaces the ending of the name. So for example, here we have sodium and chlorine in a compound. In this compound here we have lithium and bromine. In this compound here we have magnesium and oxygen. In this compound here we have iron and sulfur. So just remember, the metal comes first and the non-metal second. So to help us along, let's have a look at the periodic table. So, and work out which is which. So sodium is over here, so it's a metal, and chlorine is a non-metal. And then we have to change chlorine to end in ide. So it's going to be sodium chloride. Lithium, is it a metal or non-metal? So we go here. Here we see that lithium is a metal. And we have a look at brome, Br. Br is bromine. It's a non-metal. So we give the metal name first, lithium. And then we don't say bromine. We add the suffix "-ide", lithium bromide. Is magnesium a metal or a non-metal? We go here. We find it on the periodic table under the metals. So we're going to write magnesium. Oxygen we find under the non-metals. So we end the name of the elements in "-ide. So magnesium oxide. Iron and sulfur. So iron on the periodic table we find over here. Iron is going to be a metal. Sulfur we find here on the periodic table. So it's a non-metal. So we're going to write iron. And then sulfur, we're going to end with the suffix sulfide. So if we have a look here, blue represents the metal and red is how we change the suffix. So sodium chloride, lithium bromide, magnesium oxide, and iron sulfide. So I want you to write the name of the compound. So I've given you the compounds on the left-hand side of the screen. I've given you the periodic table, so you can press pause and you can see if you are able to write the names of these compounds. If we just go over the rules first, you write the name of the metal first, and that's the name of the metal element. You write the name of the non-metal, you leave a space, the name of the non-metal second, and you end the non-metal with the suffix IDE. So, how good were you with answering those activities? So, Li, lithium oxide, KCl, potassium chloride, CuO, copper oxide, NaBr, sodium bromide. So again, remember that we leave a space between the two elements that make up the compound, and we write the name of the metal first as it exists as an element. We write the name of the non-metal second, and we change the ending of the non-metal with the suffix IDE. So what do we do when we have to name compounds that only contain non-metals? So if we have a look at the rule, the name of the element further to the left on the periodic table comes first, and it's followed by the name of the elements further to the right. So the name of the second element changes slightly here as well. We use the suffix IDE, which replaces the ending of the name. So for example, oxygen becomes oxide, fluorine becomes fluoride, chlorine becomes chloride, nitrogen becomes nitride. And then we have a second rule that goes with that, and that is when two or more compounds have different numbers of the same elements, what do we do then? So both of these have got carbon, both of these have got oxygen, but here we only have one carbon and one oxygen. Here we have one carbon and two oxygens. So how do we show the difference? So yes, they both contain carbon, but how do we show that this one only has one oxygen and this one has two? Well, here we use prefixes. So in this case, we use the prefix mono because the word mono refers to the number one. And here we use di because it refers to two. So on this page here, I have given you some examples of the number of atoms linked up with the prefix. So if it's got one atom, we give it the word mono. 2 atoms, di. 3 atoms, tri. 4 atoms, tetra. 5 atoms, penta. And I doubt for grade 9 you'll be dealing with a greater number of atoms. So this should be sufficient for now. So if we just have a look here, if we have compounds of carbon and oxygen, so CO, it's carbon monoxide. So we write the name of the nonmetal that appears first on the periodic table. There's only one atom of oxygen, so it's mono. Okay? Just while we're on that topic, just have a look at how we say it. We don't say it's monoxide. Okay, we don't keep the double O, we don't spell it with a double O. It just goes to monoxide. Okay, so just be mindful of the spelling. So if we have CO2, the nonmetal that's first on the periodic table, we write that down first. So carbon becomes first. There are 2 oxygen atoms, so it's dioxide. How do we name the compounds of nitrogen and oxygen? So nitrogen appears first on the periodic table. And in this case here, we have nitrogen, and in our compound, we have 2 oxygen atoms. So it's dioxide. Here, we have nitrogen that's got 2 atoms and oxygen that's got 4 atoms. So we keep nitrogen the same because that appears first. But to show that there are 2 atoms, we call it dinitrogen. And then for oxygen, it's got 4 atoms, and we put the prefix tetraoxide. But now, if you notice, we don't keep the A tetraoxide. We actually drop that A, and it's just called tetroxide. I know it gets a little bit tricky, and this is probably dealing with more grade 10 chemistry, but it's important for you to understand nonetheless. So compounds of sulfur and oxygen. So sulfur appears first on the periodic table. So that's why we write sulfur, then a space. This compound has got 2 atoms of oxygen. So that's why it's dioxide. And here in this compound here, it's sulfur. It's got 3 atoms of oxygen. So we call it trioxide. And then lastly, rule 3. Many compounds are not usually referred to by their systematic names. So often we're just going to use their common names. So for example, we use water for H2O, ammonia for NH3, and methane for CH4. So again, please will you just check with your teachers when you get back to school, which compounds common names are they wanting you to learn for grade 9? It really differs, and different teachers like you to learn different common names. So if you'll just clarify that up with your teachers when you get back to school. So we've got a little activity. You will find it on our worksheet cloud downloadable worksheet. So if you go and have a look there. Basically, what I have done is we've given you the formula of the compound, and in some cases we want you to write the name of the compound and then draw a picture of one of the molecules. What might be fun for you to do here is for you to go back and get your coins or your molecules or Play-Doh or buttons or counters or whatever you've got at home and build your diagrams as you go. It will really help with your understanding. So just to elaborate, what happens if there are more than 2 elements in a compound? So what do we do in a case like this, where in this compound we have 3 elements, copper, sulfur, and oxygen? Or this compound here, where we have calcium, carbon, and oxygen. Or in this compound here, where we have hydrogen and sulfur and oxygen. Or in this compound here, where we have hydrogen and nitrogen and oxygen. How do we go about naming these compounds that have more than 2 elements? So here's another set of rules for you to go by. The last 2 or 3 elements together form a group. So if the group ends contains oxygen, it's going to end in ate or ite. Okay, so ate or ite depends on the amount of oxygen atoms in the compound. So in this case here, where it ends in oxygen, where it ends in 4 oxygen atoms, we ended in 8. Where it has 3 oxygen atoms, it's ite. Okay, when we're having a look at nitrogen with an ending with oxygen, it's nitr, and what we're going to do is there's 3 compounds, so with nitrogen, 3 atoms of oxygen, it's 8. If we have 2 atoms of oxygen, it's ite. When oxygen is at the end with carbon, we call it ate. And when we see oxygen has combined with hydrogen, we refer to it as hydroxide. So, hope that helps you with a little bit of extension thinking. So, I know often I expect the pupils I teach to know the following compound names and formulae. So, because we haven't necessarily done how the atoms bond, it is sometimes difficult to learn the naming of the compounds. But for the other chemistry that lies ahead, it's often easier for the pupils just to have learned the names of these compounds, especially when there's more than 3 elements in a compound. So the common name ammonia we often refer to as NH3, carbon dioxide, CO2, hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, hydrogen oxide or dihydrogen monoxide is water, H2O, sodium hydroxide is caustic soda, it's NaOH, and sodium chloride, that's table salt, is NaCl. So I know particularly in the section when we get to later on in the year when you're dealing with acids and bases, I know at that stage your teacher will really need you just to know the naming of these compounds. And then also just a reminder, remember that the following elements are found naturally as diatomic molecules. So that's hydrogen, oxygen, nitrogen, chlorine, fluorine, bromine, and iodine. And there are 2 ways you can remember it. One is have no fear of ice cold beer. Or the other one is I bring cookies for our new home. So either one you can use to help you remember which elements are diatomic molecules in their natural state. So let's go through some questions to end off our lesson with some evaluation to see that you understand what is going on. So you can pause the screen, you can write down these 10 compounds, and I want to see if you are able to provide me with their names. Remember all the rules. So COSO4, remember, calcium, we just write that as a name. Now SO4, because this is made up of 3 elements, we combine these last 2 together, okay? So that's sulfur, and because there are 4 atoms, it's sulfate. If we just go down here at the bottom, SO3, there are 3 atoms. So with magnesium, SO3, magnesium is going to be the name of the metal, but the SO3 we combine and we call that sulfite. So when sulfur combines with 4 oxygen atoms, it's sulfate. When sulfur combines with 3 oxygen atoms, it's sulfite. So here, lithium and bromine, we're combining a metal with a non-metal. So we write lithium, leave a space, and then bromine we end with the suffix "ide," bromide. Sodium is the metal, And because there are 3 elements in this compound, we combine the last 2, and sulfur, when it combines with 4 atoms of oxygen, we end it in 8. So that is known as a sulfate. So sodium sulfate. Here we have a metal mixing with 2 other elements, a carbon and an oxygen. So because there are 3 elements in this compound, we combine them together and we call it a carbonate. So when oxygen combines with carbon, it's a carbonate. Here we have a metal with a non-metal. We write the metal first, potassium, and the non-metal we write it second, and we add the suffix "-ide". NaCl, Na is the metal, Cl is the non-metal. So we write the metal first, sodium, leave a space, and instead of writing chlorine, we end it with the suffix "-ide", chloride. We have nitrogen and oxygen, so these are both non-metals, and it's nitrogen oxide. There is only one, so you could have written it as nitrogen monoxide. We have magnesium and sulfur and oxygen, so there's 3 elements in this compound here. Magnesium is the metal, so we write that first and we leave a space. Sulfur is combining with 3 oxygen atoms, so that's referred to as ite, so it's magnesium sulfite. Here we have a metal and a non-metal, copper oxide, so we write the metal name first, copper, we leave a space, and then we end it with the suffix "-ide". And then we have iron. Iron is the metal, sulfur is the non-metal, and we write iron, leave a space, sulfide. So here's some more for you to practice. If you need to pause the screen, you can. So here are our answers. Some of these got a bit tricky, I know. So we have 3 elements here. The last 2 elements combined together. So we have copper sulfate. Why is it not sulfite? Because there are 4 oxygen atoms. If we go down here we see SO3 combines with 3 oxygen atoms, and we end it with sulfite. CaCO4, calcium, and then CO3 is carbonate. CO2, carbon dioxide. CO, carbon monoxide. H2SO4, well, you can either remember the common name, sulfuric acid, or we can say it's dihydrogen sulfite. Magnesium oxide, and then the common name for this is known as nitric acid, or it will be hydrogen nitrite. Some of these are a bit tricky, but again, just check with your teachers the level of difficulty they require from you. So you can also have fun if you go onto this website here. You might need to download it, but hopefully it does work for you. It is a wonderful simulation where you can go and build compound molecules and learning naming of molecules and things like that. So pause the screen and copy this website down here. It is a wonderful opportunity for you to deal with an online simulation and reconfirm your understanding of the naming of compounds. So to summarize today's lesson, I would like you to write down 5 questions related to what you have learned today. And each question must start with a different word. If you want these questions answered because you're not too sure of the answers or you're unable to find the answers, please will you email your question to grade9@worksheetcloud.com, and we'll get back as soon as we can to you with the answers to your questions. But give this a go. So you can use any of the question starters at the bottom. What, who, when, where, why, how, and best of all, what would happen if. So see what questions you could come up with that will cement and confirm your understanding of naming compounds. Grade 9s, thanks for watching the lesson today. It was brought to you by Worksheet Cloud. Looking forward to seeing you all again tomorrow. Bye.